Alright, in this video I'm going to assemble a CylinDraw plotter from start to finish using one of the kits that I sell on my website. The process takes about 2 hours. I'm going to do my best to keep the video as short as reasonably possible, but I think this will be an important supplement to the step-by-step instructions that I have, and maybe I'll mention something that I didn't necessarily point out very well in there. So I'm going to start by highlighting a couple documents here that are all available. All of the above that I mentioned is available on the CylinDraw website, the Downloads tab. There's a bill of materials with a list of every unique part that is on the machine and the name of the bag that you're going to find it in, and also a bolt layover chart to help you identify the unique parts. But I went to a lot of trouble to design this machine with the fewest possible unique parts I could to make it easier. So I'm going to switch the camera and get going. Okay, I've got you posted above my workstation here and a little mini view of my screen, which I'm going to pull up to the PDF instructions. And make sure you can see, yep, you can see the right stuff. And go down to step 1, software test. This is step 1 because it's so important that you make sure that you have a Windows PC, because at this time, this software only works. The only available software for the CylinDraw is for Windows. We're working on cross-platform solutions, some browser-based stuff, pretty cool, but it's not out yet, so be aware. Step 2, collect tools and materials, pick a kit. What I've got here is kit option number 2, where we 3D print everything and you assemble it. You can 3D print your own stuff. I've got the STL files for the kit on the website, on the download section. It's free, it's not open source, so I appreciate not sharing it or remixing that. But you can tell your friends where they can find the files, which is right on the website. Let's see, more description of tools. I'm going to bust those out next. First, I want to show you, if you did 3D print your own parts, the only things I use for post-processing are an 8mm reamer or a drill bit. Reamer if you want to be really fancy. A 5/16 18 tap, and a razor blade for some deburring. There is very little post-processing that these parts require, which is by design. Let's see, the tools. There's images of the parts there. Actually, the names of the 3D parts in this image, it has their, oh, I guess not in that image, but the one on the website, it has their name and an underscore, and then the number, the quantity of those parts that are in the kit. So that's kind of handy. Alright, so step 1 was the reamer there. Begin assembly, review vitamins. So I'll just show you what we got here. Referring to this list, it has names of bags and what's in them. These are the bags, there's the name. I've got spare parts. This is if I miscount a screw or you drop a screw, there's some spare small stuff and consumable stuff in here. Servo. Super glue. Actually, there's only one super glue in the whole kit, and that we're going to use that. I'll set that aside. That's what that is. Hard parts, it's nuts and bolts. Heavy stuff. Tools and long parts. We're going to start with that one when I open them. Soft, squishy parts. The engraving parts, there's only a few in here that you need for that. Cables. 2 motors. A cup. And with the Arduino Nano inside, it's fully, that's important, I'm going to point that out right now. The Nano, we ship them assembled and tuned. We have to adjust the potentiometer on those to match the current level that the steppers are expecting to be driven at. And if you don't do that, bad things happen. If you adjust these not carefully, you can let out the blue smoke. I've done that enough times to know that I should do it for you. And what else do we have? It comes with this platter with the protective tape. Tear it off of there. Get all the little bits off. It's laser cut. That keeps the edges from getting scorched in the laser cutter. Looks great. And then a box of parts. There's the list. There's the engraving stuff. Let's see, yep, and assembly frame. We're going to start with the frame. I'm going to start by getting the tools out, actually. Put the bags aside. Man, this gutter is so handy, by the way. Hat out of the way. I'm going to pull them out so we've got them handy. Our screwdriver, little 3D printed wrenches that fit 5/16 nuts and the adjustment nuts. 3 unique sizes of hex drivers. Long stuff. We'll get those out of the way. Our first drawing permanent marker, a fine liner. Don't need the bag. We're going to assemble the frame. Get this guy. I'm going to lay him out like the picture. This is asymmetric and there's a top versus a bottom. So for my orientation, I know that this is the top because of this little space right here. It's going to end up being this part that goes there. I know that this space will need to be there, but you know what? If you do it wrong, you'll realize it and you'll flip it over and there won't be any problems. So oriented like the image is showing it. I'm going to get 1, 2, 3, 4. Get some of these things out of there so I can see what's in it. Okay, for these little guys, I'm going to see if you can see that. I'll assume you can see that. This little thing is designed with like an S so it can kind of squish a little bit. Those are going to be our locating pins to aid assembly. Got the 2 biggest pieces. Here's a little, that was handy. So this is nice to have. Not, oh, look at that. Didn't even need it. I printed them. Don't even need the hammer. I'm getting ahead of myself. You just pop them in the bottom. There's no wrong way to do it. I need the hammer on that one. Oops. Alright, so now what that does is it goes into the pin and slot, just like that. And on the underside, there's 2 screw holes. You can't miss them. Get that nonsense out of here. The driver. Okay, so I'm going to get those screws from our hard parts. The hard parts bag. They are the longer plastite screws. There's only 4 of them in this whole bag. And they look the same as the short plastite screws, but they are longer. So it's this one. You might have done well to get like a bin to dump this stuff out and to kind of reach it a little more easy, but that would be there. That would constitute planning on my part. I'm going to get this. Oh, do I have a magnetizer in here? You can use one of these disc magnets that come in the kit. Actually, in that bag too. I just grabbed one from over there, and you can hold it handy like that. It's kind of a neat trick. Jam that in there. Now the pin does the locating to keep it square and oriented, and the screw only retains. Let's get it all the way in. You know what? I'm going to use this other tool here. Make it go a little faster. Just for the sake of a video. Got them in. And then I'm going to put the feet on the bottom. The feet, put those things back, keep them together. The feet are located in the soft parts bag. They stick on. They're this rubbery material. I'm going to put 2 in the middle to keep it from sagging over time. Yeah. Just put the rest on the corners. Nice non-skid feet. Throw that away. That's what it's supposed to look like. Step 6, assemble the rotary axis and chuck. So install the motor. So I'm going to set this back and grab the motors. They come with these little dampers. Some of the kits have cork, some have a foam. It makes no difference, no functional difference here. I did want to have some sort of buffer between the metal and the plastic, but they operate at temperatures that are safe for the plastic. I actually print any part that touches the motor, I print it out of PET G to give it a little extra temperature resilience, but they are designed to stay at a happy temperature. So right now I'm grabbing the flathead screws. You know what? I'll get this. I omitted that. Darn. It's the 3mm flat topped screw. It's Phillips. It looks like that. There's only 4 in the kit, and they're for this specific purpose. Let's see, there it is. Take it out of there. Hold it up, and then the motor has a side to put your cable into it. I'm going to point that side facing towards the table. I'm going to install it right through here. Now I'm going to screw them in. I'm not going to screw that one in hard until I get all the screws in so they can find their way to where they belong. I think the insulation's gotten in the way. There. Yeah, so I'm going to screw the screw until, whenever they're all in, until the head of the screw is flush and even sunk in a little bit on the plastic. I want that thing to be secure. There we go. Okay, keep going. It's still tightening. Tiny bit. And try and get them all even too, because you could cockeye the motor a little bit if one's super tight and the rest are all loose. I think it'll be forgiving. That feels good. Actually, looks like I didn't tighten the frame in all the way. I feel it. Nothing should wiggle. There we go. Okay, now I'm going to set the whole thing aside for just a moment and get this piece, the chuck here that has the part flipped up, and then one of two of these that are in the kit. And here I'm going to pop off. Just got pliers. It looks like it's machined out of a solid cylinder. It's not. It's pressed together. Oh man. Pause this thing and rip that off. Okay, there. That did it. I took 2 pliers and I put them like this and I pried it off. Toss that little piece. Make sure I'm still recording. I don't want to continue doing this later. That looks, yeah, that's right. And that's gonna go in there. You can see how it's like toothed like that. Now, making note of the 2 set screws on the side here. This plastic piece also has 2 set screws, 2 openings for them. So you have to get that lined up. Try to. There we go. Okay, so this is helpful. I'm looking at down this view. I'm looking down the hole and then holding this other piece in my other hand. Now it's very clear. It's very clear that it will be aligned when I get it in. So it's stuck a little bit. It's probably cocked on the tooth just a little bit. You know, I bet it would be much smarter. This is what we'll do. Is that? Oh, yes. Oh, yes. It goes on the end of the screwdriver like that. and so I can turn it once it's in there. Where are we going home here? There. Okay. It's a tight fit because you want this. This is fusing this piece to the, affixing it to the motor shaft. You don't want it to be able to move. So there's no clearance, and that's why it's tight. But I got it in, and I can see, how did that happen? I can see that I've got my angle wrong here. I'm gonna, okay, so the motor's installed on here, everything's secure. I'm going to move it to the back here for a minute. And on this step, I'm going to fish out of our hard parts bag. I'm going to grab the tooth driving pulley. There's two in there. I've taken one of them, and I use a couple pairs of pliers, and I put them, you know, I grabbed it like this and pried on it to peel off the end of it, because it's actually just pressed together. It looks like it's one machined piece, but it's not. And I guess I want to also point out to make sure that the tiny set screws that go in those holes are actually there. I make sure that they're there before I ship them. I'm warning you because whenever I receive these, usually a couple of them are knocked out, but they're in the bag that they come in. So I pop them in and I screw them all the way down to make sure they don't come out. But you got to check for that. So we have that. And I'm going to dig out the chuck piece. It's the only one that looks like this. It's got this little spline built into it so that it's going to mate with this part perfectly. What this is going to allow us to do is affix the chuck to the motor shaft with two set screws in a way that's permanent. It's not going to jiggle off, and that's what's necessary. So we are going to use our screwdriver, and the set screws are actually pointing into the hole right here. That's going to help us. I'm going to put it through here, put it on the end, so I have control, and then look at the side from my view right into this hole so that I know I've got them lined up. Poof. Pressed it in. I can see that set screw. I can see that set screw. And you'll notice that this one's actually in the printed part. There's a slot there because different manufacturers have different angles on that machined part. So this needed to accommodate both, and that's why that looks that way. But pop my thing out. It's all the way in. It feels good. It looks, there we go. It looks like it's all the way in. That's very important because you don't want these to be attached at a weird angle. So I'm just pushing on it. I just want to be darn sure. And I'm going to get my super glue from the spare parts bag. There we go. You know what? I've actually got a super glue that's open. It's not one-time use, somewhere around here. Maybe save that little one for something else. And just go all around the edges here. This is important that this joint becomes permanent. Like, it's already not rotating. The glue is not going to take the stress of the torque. It's going to just make sure that they stay together. Oop. And not too much on the inside. I don't want it to bleed over onto the threads of the tiny set screws because you'll never get them out. That would not be, do not allow that to happen. That would not be good. So, I guess if it did, grab a Q-tip real quick, probably put some isopropyl alcohol or something on it. It's the best I can tell you. Suck it out of there. I'm going to let that dry for a while and set it aside. Let's see the instructions. The instructions tell you to go ahead and put, that's where that's going to go. I want this to dry while sitting level so that the glue doesn't pool to one side. So I'm going to set that aside for now. And now I'm going to move on to this other step. I'm going to grab the 3D printed nut piece. This is a little finger nut that actually does happen to fit into the 3D printed wrench tool I showed you earlier somewhere. It's in the tool bag. Oh, there they are. That's just kind of nice to have in case you don't want to use your fingers to tighten stuff. I'm going to get that. Actually, I'm going to get every one of those I can find. There should be 6 in the kit. Maybe even 7 if I threw in an extra one, in case something gets dropped or miscounted on my end. And then grab the 3mm nuts. They each get 1 in there because I don't like threading machine screws into plastic on a joint that's going to be repeatedly inserted because they wear out. Right? Machine screws threads are too fine. Anyway, I'll dig the rest of those out off camera. Let's see if I'll show you a little technique here. I'm going to get just any of these M3 screws, put it on there a little ways, and then press it in. You can either tap on it with a hammer on this end, or you can do the opposite. You can actually see. And I'm instructing you how to do this because it's a tight fit. Like obviously, just get the nut in the hole, but it's tight because it's tapered. You never want to have to do this again. You never want them to come out, is what I'm saying. Put it in like that, and then screw it in all the way so that it's pulled in place. That's a really good way to do this too. So I'm going to pause it. That's tedious. You don't need to see me do that. Okay, so having just done that 6 times in a row, I can definitely say putting the screw into the hole first, then screwing the nut on all the way down, and then actually putting it in the tool to hold it in place while you torque it until you pull the nut all the way down to make sure it's fully seated. That was the way to go. Okay. Well. Okay, I took a little break for the night and got some sleep so I can get back at it fresh and let this glue dry here. So that's dry. I'm going to put it on, noting where the flat is on the motor. And this has 2 set screws. I'm going to want to use both of them, actually. Both actually do provide value, even though only one of them goes on the flat. Usually when you're drawing, it doesn't matter, but if you're going to do engraving, that's some high vibration stuff. And you want to grip it in both places. So do that, and I've got my super long tool. Tighten it on. I push this on all the way. Actually, let me make sure that I did, in fact, push this on all the way. All right. There. Yes, I did. Okay. Tight. And tight. And I take this piece here, and the little recesses go on the side that you can touch with your fingers. So that can help you grab it and do that. And you just put it on over the end like that. And oops. Yeah, this suggests to me I may have needed to tighten those a little bit more so that sticks out a little farther in the center there. Yeah, that did it. There we go. Make sure this thing's all the way on, and now the center of this is just sitting on the end there, and it keeps it centered, but the motor shaft is not protruding through. Now I went ahead and did these guys. I grabbed the 4 grip 3D printed parts, and I took 4 18mm long screws, and I just threaded them through. And then I actually put a little dab of super glue on the end just to make sure that they don't, that the screw cannot rotate within it once it hits the end. Just want to keep it there permanently. Here we go. Since we already are using super glue. Oops, which one was that? That was this one. No, it was this one. There, so I did that to all 4 of those. Now I'm going to take my nut here, take this tool. This one looks a little out of round. I'm going to want to make sure it's all the way to the bottom. Alright. And just push it through so it lines up through the holes there. Thread the nut on. That's all there is to it. I'm going to do that 3 more times. Pause it. Okay, now that's done. Next thing I'm going to do is go in the soft parts bag and get the 4 sticky, what did I call that? Sticky tacks pads. Kind of an interesting little thing. It almost feels like silicone. Just going to take it. I'm going to take it off of there. Let me see. I better follow my own directions. Yeah. I take it, get the sticky backer off of it, fold it in half, hot dog stuff, or I guess it's hamburgers. Fold it in half the only way you can, and then take it and stretch wrap it all the way around so it sticks to itself. There we go. And then squeeze it so it kind of like merges onto itself. This is a really weird material. It's not quite glue and it's not quite silly putty exactly. We're not really concerned with the stickiness long term because like I'm unsticking it with my dirty hands right now. What we want is the jelly, the squishableness of the jelly and the I guess the friction that will provide. It gives you something, a buffer between a smooth cup and a smooth plastic rod, and it helps tremendously with preventing the cup from rotating. So I'm going to pause it so you don't have to watch me do this 3 more times. So I'd unpause it again and show you real quick the method I just tried another way that worked really well. I just leave the whole square like that, wrap it around, stick it to itself, and then just shove the excess inside there, and that's actually looks really good too. Either way, you can experiment a little bit. There's some extra ones of these in your spares bag. So I'm going to get the parts out for the next step. Okay, so I scooted the other stuff aside we were just working with and move into the next step. We're going to, step 7, it's assembling the live center. So I gathered all that stuff so I don't have to dig around. All the nuts and the spring and the screws came from the hard parts bag, and this came from the longs bag. So I'm going to start by using these little knobs, the round knob, and putting our little short plastite screw in it, like that, and then screwing it into the end of this knob, and then tighten it all the way down, and then loosen it, let's say a 1/4 turn, and here we go, just like that, so that it can still spin in place, so you can kind of rotate your hand like that. So, like that, and in the center of the piece in my hand, we're going to press a nut. So I'll just probably see if I can use this threaded rod to kind of get in there. Yeah, with things like this, I always taper the hole too, so it goes in, starts to go in easy, and then it pulls itself in to a depth that it won't come out of. And if you're making your own parts, or if it just doesn't come out to tolerance, you can always put a tiny bit of super glue in like the corner there, just to like, you know, retain it so it doesn't pop off. If that were to ever happen. And let's see. So I've got my. I'm gonna go ahead and use this frame here. Put nuts in either side. I'll just use the tool for that same process. As far in as it'll go. I actually got a bolt in the bag I can use for that too, just for that purpose. There, it's in. But to retain that, I've got these two Plastite screws just like that, and just tighten them down as far as they'll go, or we'll say it differently, tighten them down as tight as is reasonable. There. Just like that. And thread the rod through. I probably should have, let's see about that. I should probably leave one of them loose a little bit so that the rod can push the nut out as much as it needs to until the threads catch, and then they'll be synced up. The two threaded will be synced up together. There we go. At the right distance from each other. You don't want it to, so you don't want it to suck to turn. That feels pretty good. Let's see what's up here. Well, you're going to get it all to the middle of this threaded rod, so it won't be in our way too much. Well, yeah, better not tighten those two awful much there. You don't want to impede the ability of this rod to turn. There, it feels great. I'm going to go ahead and use this little knob piece, insert my nut. These nuts are not expensive, and this is just a better way to do it than threading the part directly through the plastic. Now I'm going to orient this so that this completely flat side is the side that goes on first, so that the force of tightening this thing will seek to pull the nut into the plastic. If you do it the other way, the nut will just pull itself out. The purpose of this part is to prevent the threaded rod from rotating from vibration in the middle of the job. So I'm going to take this assembly in my hand and another nut. I'm going to assemble it with it's going to stay on by tightening the nuts against each other. And on, there we go. And on the exterior side, you don't need to leave any exposed, just to the end of the thing there. Now these little wrenches, this is what they're for. There it is, not going anywhere. On this side, you get my remaining 5/16 nuts. There's two more normal nuts and then a nylock nut here that's still in the bag. I'm going to start with the normal ones. Throw on the spring. And throw on this guy, this cone here, with the point of the cone pointing towards the chuck here, like that. And drop on my nylock. And let's see. Move this over. Use that to tighten the nylock on. And the very last thing I'm going to do is set the compression of the spring. I want to get as much compressive distance out of that spring as I can without leaving any jiggle. Let's see here. So just like that until the nut just barely starts to touch it. That feels good. Yeah. And then tighten these two nuts against each other. Yep. That's it. So that allows us to get the compression while rotating. This piece just sits on it like that. Or if you're going to do like a shot glass type of thing, you need a little extension just to get a little more length out of it. I didn't want to include a rod that was longer than a standard 12 inches. That's where that gets you. And this piece can also be used for pushing on the bottom of a cup. It's like, like this. If you need to, like if you're going to do a mug in an upside down orientation. So I'm going to leave it like this. Oh, I've also got this part. We don't have to attach this. This is an optional part, but I've found if I'm engraving something big and heavy like a glass mug, like you just want as much stability as you can. Just like that, and the weight of the situation will kind of hold it down. So don't need it right now. Yep, using the tool. Okay, now I'm going to put all this stuff aside, and we're going to get stuff out to assemble the linear axis. Okay, I got my stuff out to build the linear axis. I got 2 rods. I got these end pieces here. Have the holes in them. I've got 3 8mm bearings. Just going to go ahead and fit 2 of them on one rod, and the other on the other rod. And the rod with 2 bearings goes in the top hole. I can use my handle to give it a whack there. So I've included a slot in the side of this piece so you can see when the rod is all the way in. That's the way to do it right there. Now you can see it. I'm going to do both. Looks good. And then I've got some holes there. I'm not going to do it. We don't have to do it, but if it turned out the tolerances of the machine needed the distance between these 2 parts to be bigger, or you needed the cable to be tighter, you could put a Plastite screw there and push on those a little bit. But I'm not going to start with that. Let's see. Oriented. The bottom side of that is on the same side here. Not that way. Just like this. Get like that. Same thing. I can see in the side of there that it's all the way down. Now I'm gonna get this piece out. This is the carriage mount, and I'm gonna orient this piece like so, and then put this on the bottom. Like that. And I've got my soft parts bag. I got some zip ties here. There's backups in the spares bag if you use them all. Shove them through the preformed slot. And let's see. Let's use these. Yeah, I did not include pliers in the kit. Like, you got to draw the line somewhere. I tried to be pretty inclusive. I put some tweezers in there. I had a bunch of those. That might be useful, but no, you just need to. Yeah, you need pliers for this job. Pull them really tight. Keep the head down, and then snip them. Okay, so I'm going to install, I'm going to get in my hard parts bag and get the idler pulley, smooth one. The inside is just a bearing, and an 18 millimeter long 3 millimeter screw, and a 3 millimeter nut. It's real tiny in there. And then set that up on this side here. There's only one way for it to be installed. Hole's a little. I shouldn't have to screw it there. The hole is just a little tight. And I'll try to push this nut in. And now I'm not going to over tighten it here. I just want it to feed through there. I'm going to back off a little bit. I definitely do not want to over tighten this because it's squeezing over open air. The purpose is just for the bolt to act as an axle for the bearing. It looks like I've got the, yeah, okay. I need to start with this picture before I move on to that picture here. I'm going to install the motor on this mount here to provide another place to wrap that timing belt around. So I'm going to get the motor. I'm going to get three more of those 18 millimeter screws. Motor comes in from this side. I'm going to orient the nub of the motor there facing towards the inside that. So this is exactly how it needs to be mounted. I'm just going to install it. I'm going to start on this side with a little hole and then do the slots. And I'm going to tighten these not even snug. I'm just getting them installed so that it sits in its track. It's not time to lock it in yet. A little cork is getting in the way. Yeah, I got it. You just gotta want it. There. The cork was just a little thick there, so I got that. Next step, I'm gonna get my my remaining driving pulley. I'm going to move the set screws. I'm gonna back them out so that the inside is clear enough to drop them on the motor shaft. That picture really snuck its way in there prematurely. Yeah. Okay, so notice the orientation of the pulley is going to go in that way. Then I'm just going to kind of look down this axis to make the center of the tooth region center to where the belt will travel. There it is. And tighten it on there really good. Yeah. Okay. Now I'm going to make sure this motor is not too snug that you can actually rotate it. I'm going to rotate it towards the system so that to give the belt as much slack as it's going to need. And then I'm going to install the belt, and then I'm going to be pulling on this to get the tension that I want. We get the soft bag, get the belt. Now it's time to do the tucking step there. That one photo was a little a little premature. In fact, maybe I can just do that. There we go, wrapped. The bottom one passes through this groove. Around the idler, and poof. So I may need to cut that, but I'll just start with one side. Now these little slots that the belt gets pushed into, I'll use this little tool here, those slots are tapered, so I'm going to push it in all the way to the bottom, or as far down as I can get it, because you need to do things like that because everybody's 3D printer is a little bit different. You know, the weather, the filament could affect it, so you're trying to squeeze something that's small to accommodate the variance that's going to show up. You got to have some taper. There we go. And now when I try and pull it out, it didn't come out. It's perfect. So yeah, provide a little bit extra on the belt. So I'm going to cut that. Just going to pull it kind of snug. Looks like I'm cutting off 2 inches. And there's a little place to wrap extra belt in there. So I'm going to attempt to use that as well. So I'm choosing a tension that is like, let's see, this is a little subjective here, but definitely not too tight because I have an adjustment factor to make it tighter. So not even snug, but the consequence of doing it much too loose is that the motor will rotate and the carriage won't move, and the consequence of doing it too tight is it is so loud. It's absurd. So normal operation, you should like barely hear it. It's quieter than my 3D printer in the background, which you're probably able to hear right now. Especially if you keep it lubed when it's new. Just all the way down. That's it. That's not going anywhere. It's definitely too loose. So let's see what happens. Oh yeah, that worked out great. I'm using up like all of my adjustability there, but the tension feels fantastic, so I'm going to leave it. Right, there is a screw hole up here for one of the regular Plastite screws. Put that in, and I can use this to press on that screw to like mechanically prevent it from coming back, and that's just an additional, here we go, poof, in addition to locking these in. In fact, I'm going to loosen that a little bit. That did work out. Just kind of backing up on that little tiny screw. Just gives me a lot of control on what that's going to feel like. I'm going to leave that. It's about what it looks like. Tighten those snug. And it's hard to pick a torque on that. It does a cork thing in there. It's serving the function of its intent is to dampen noise and to keep just a heat buffer between the metal and the plastic. You know, just in case. Plastic it has a property called creep where it can deform really slowly over time, so that's kind of what I was trying to avoid. I haven't observed it in this project, but anyway, so I'm going to put that little guy, I'm going to dig in my plastic bin, this little wire clip. And I'm going to take one of my plastite screws. You could go in just straight through the top, the obvious way. I'm going to put it in like this, squeeze it. I need safety glasses for this. There we go. Like that. So now I can slip wires in and out to restrain them without undoing the screw. And I've picked in the photo the nearest screw hole, but there's a couple to choose from there if that turns out that I need a different one. There it is. There's my routing hole. Oh, and then next we're going to get in the soft parts bag and get our end stop. And I'm going to take this thing. I'm going to show you what I do with it. The wire. This is what I do with the motor wires. This is a pro tip here. You just twist them until it just wants to start jumping up there. And now what that does is if I ever wanted it to be longer, I could untwist it, but it's taking up a lot of that annoying slack. And this is a nice off-the-shelf cable with nice ends, so I didn't want to try and cut it or hack it or anything. That's that. Here's the switch. On the back side, it sits on these three, and only one screw is needed to retain it. Let's get that all the way in there. In fact, I'll even back off the screw a little bit. There. So it's pinching it down funky. There. Yeah, so the switch is a commodity part. They're all a little different, so you got to make sure it has the. But yeah. There. Excellent. Okay. What's next? So I was playing with my switch, and I decided, like I said, the commodity part, they're all a little different. The one I prototyped with had shorter leads on the bottom than this one does, so I'm going to cut these off on the bottom. Doesn't affect the functionality of the electronic functionality, but it does affect the clearance down here. There, now it sits nicely without rocking. And I hate to have to do that, but it is what it is. Now a single screw locates it and secures it completely. That's all you need. Okay, now I'm going to dig out the rest of the carriage. The carriage cover piece. Dig out this nut piece. I'm going to get an 18 millimeter long screw and a 3 millimeter nut for that. Yeah, just one. And I'm going to clean out the hole. Actually, the print had a little goop in there, a little burr. That's good. I'm also going to need my magnets, which are in my hard parts bag. And then while I'm at it, magnets, get your super glue, get this carriage cover piece with this hole pattern here, and this piece with this hole pattern. And we're going to glue the magnets in so that those two attract each other. Now's a good time to do it because both parts are free and accessible, and you can do it and give them time to dry for when you move on. I'm going to pause it and I'm going to do that. Okay, I've got these two parts glued so they want to mate to each other. Glue is dry. I'm going to mount this on here. There's only one way it could possibly go on. And I'm going to start with the two screws in the center because this plane here is actually a little higher than this plane, and that's so it functions as a datum surface to make sure that the I guess it was so I made sure the magnets were at the right height. There we go. One, two. All the way down, and then the rest, yeah. It may not make a noticeable difference to do them out of order. And you know what? They don't need to be overly tight. I felt like you can strip it here because you can see that the screw is actually traveling over open space before it engages. So there's not very much thread engagement. So on those exterior fours. So yeah, just a little snug. That's good. It's just securing the piece. Next part, we're going to grab this little finger knob and a 3mm nut. Just press it in the end, and then a 18mm long 3mm screw. Install it. Okay. Just pull it in. Ouch. Let me just get it the rest of the way in, and I'm going to put a dab of super glue in the top there. I think that's optional. I think it's probably get that joint really tight there, but it's probably just fine. But I'm going to put it in there because you never want that to come back out. It would just be an inconvenience if that was to start spinning in place. And let's see. Okay, we're going to assemble these parts onto the back. Slide this piece away. I'm going to grab what I call the flag. This is the part that sits on here, and it's adjustable to touch this. And on the side farther from, there's two holes in the middle here. This hole, it's farther from the end of the flag, is the side I'm going to install this at. And I'm just going to thread its way in there. Metal into plastic, but there's going to end up being about 20 threads engaged, and this one is not highly frequently torqued down too hard. So I think it's a good connection. There we go. Excellent. Well, there. Excellent. Good enough, because it's something you're going to be just doing that on. Anyway, next is a regular screw that just goes down, and we're not going to tighten that permanently. It's going to be left up high enough that you could slide this. It's just to constrain. Yeah, and you'll never adjust that little one again. There. And then I'm going to set up 3 of these little wire harnesses with inserting the screw inside them and then installing them on those holes right there. And I'm going to pause it while I do that. Okay, so those are installed, and notice the orientation of those is intentional. They're all kind of pointing towards that side. And we're going to scoot this assembly to the back for a minute and build the carriage itself. So I've got this piece, the carriage part. Now that little square there is actually a separate 3D print that I've inserted into a slot there for you, but just so you're aware that that is done that way. If you print your own, you get to do that. Just press it in all the way. You probably don't even need to glue it. It's press fit. Okay, so I'm going to grab out of my hard parts bag the 6mm bearings, and I'm going to get my pin and mark. So inside, if you look down the hole, there's 4 rows of bearings. I'm going to mark the pin right there to show. Yeah, that's good enough. Oops, I'm trying to be accurate. To show right where a line of balls is on that, and that will help in a minute when I'm assembling it, and it gives you a tiny bit of adjustment that you can apply to make your assembly tighter or looser. There, that's good. I'm going to get the carriage portion of the carriage that gets lifted. 2 3mm screws, looks like the last 2 in the bag, and then 2 of the 3mm screws. And same situation, these are going to get permanently fastened inside this piece and then live in it. Well, it looks like I get to deburr that a little bit. It's kind of blocking the head of the screw from going in. There. Just like that. And pull it in, and you're never going to be taking this bolt out again. Okay, next I'm going to get the 2, these are shoulder screws. I'm going to be grabbing the longer, narrower diameter one. These are 6mm, the others are 8mm. And throw a bearing on and install it. Now in here, I'm actually going to clean that up with my screwdriver a little bit, just jam it in there and get whatever, if there's any strings of 3D print left over in there, get that out. Drop this in, and I'm going to screw it down until the shoulder rests on an edge in there. I'm going to use the middle-sized Allen wrench to do it. Looks like they're in there all the way. I'm just going to look at it. It looks level. That's kind of another hint that they're in there all the way. That and it being too tight to turn. Okay, now I'm going to install some zip ties. Now this part is critical. Let's get out 3 zip ties to start. I'm going to take the assembly, the pieces oriented like that. Feels awfully tight. I probably need to, yeah. This part's got a little warpage on it. I must have been playing with that. So I'll hack on it a little bit here. You shouldn't have to do that, but if it's got burrs from 3D printing that get in this feature here, it changes what the dimension's supposed to be. Okay. Yeah. Okay, I just paused it and gave this thing a blast with the heat gun for about 3 seconds on each side on their trough, and then I pushed it in like that. That is not something you should have to do with a kit that you buy from me. If you make it yourself, yeah, that's reasonable to expect you to do. This is the intended fit right now. It's just like very freely fitting in there. And what we're going to do with the zip ties, I'm going to take 3 and pick either side. It doesn't matter. I'm going to insert from the back, just like this, all 3, and then I'm going to tighten them as hard as I can, all 3 of these. And let me see, I'm going to take that row of bearings. So here's the other part of that. Once this is fully assembled, if you have this line positioned here, lined up between line, rod, and rod, then that's going to make this assembly tighter. And if you turn this at 45 degrees, then it'll be between 2 rows of ball bearings, and there'll be a little bit more wiggle space, just a tiny bit of adjustment. But sometimes that's all you need. It's a good trick to know. So I'm going to start out with it. I'm going to go for the tighter orientation, and then loosen it after the zip ties are all tight. I'm going to leave the head on this side here, the head of the zip tie, so it's on the back. You can't see it. There, rock solid. So that's what's securing securing these 2 parts together. It's the primary means of securing. And then the next 3 zip ties that I add on this side will just be to prevent minute rotations. This is the primary security though. If you tighten these 3 really tight also, it'll be over constrained. It'll be too stiff to move, and we're relying on gravity to lift and drop this thing, so you can't be letting it be stiff like that. So let's see. That's it. I'm not even going to use the tool to pull those tight. Actually, that's just all overkill. I'll end up overkilling it. You just really don't want to overdo it. That's it. Clip them off flush. And then I'll take my pliers and rotate those bearings now that everything's tight. 45, so it's kind of facing that way, and 45. There we go. As long as it doesn't stay up whenever I let go, we're golden. And since those are ball bearings, you can put a little bit of machine oil, not grease, but free-flowing oil in there. It'll do it good. Set that aside. I'm going to bust out the servo. I've got that. I gave you a spare in the spare parts bag and one in the soft parts bag. It comes with servo, and it comes with little horns and screws. 2 of these screws are for mounting and 1 is for putting the horn on. I'm going to leave, so here's what I'm going to do. These are garbage. This horn and then the screw that doesn't match the other two, I'm going to put them back in the bag and hold on to them aside for now. And we will add that on later when we know exactly what the orientation of this shaft is rotationally, and when we connect it to the computer. And for now, there's an arrow on the top of this part. You'll notice that this servo is asymmetrical. It goes this way. Let's see, match that up, just like that. So the head of that is over the arrow, and then screw it on. And be careful with these little tiny screws like this. Tighten them all the way down, but then be wary of when the screw is seated, and not continue torquing it, because you can shear them off. They're so small. That's all it needs to be. Is just keep the servo from moving. Like that. Looking good. And I've got, yeah, I'll do it now too. So this part has 2 holes on either side. I was originally leaving myself open the option to attach this on either side, but this part is unique. It won't even fit on the other side. So excuse me, you lay it down like that over the holes and drop a couple of Plastite screws on there. This holds your vacuum for engraving, collecting all the powder and dust and stuff. It's necessary when you're engraving. It doesn't do anything when you're drawing. Maybe you could mount a camera to it or something. It's a nice spot for that, but it's not in the way, so I'll do it. And then let me see. Actually, the engraving bag has, I'll just grab that right now. It has 1 long Plastite screw, and I'll put that in this part here. Set. Follow my directions here. Yep. That's what that's for. And that's long. That's why it's long. It's in case your hose has a larger diameter than this and it needs to stretch outwards. It gives you a little more options. Preserve options. Step 10, subassembly integration. We're going to put the carriage on this guy. Make sure I'm still good. Yep. I'm going to take our largest hex key and one of our 2 remaining 8mm shoulder bolts. There we go. And just drop this on, so I'm looking at the front of the machine. And this is a pivot point, just like that. Now I have taken my 8mm reamer and reamed out all the holes. Actually, I should be specific. This piece has been reamed. These 2 have been reamed. This piece here has been left alone because that is going to receive the threads of this here. I'm going to tighten it in up to the shoulder until it hits like that. If while doing that you discover that the hinge is too tight, that you can't lift and lower it, then you can loosen this a little bit. Here. Wiggle it in there. This is an alignment issue. That's where I'm not actually threading it in anything. I'm just hoping turning it actually gets it to feed. going to get it out, see what's wrong. That should feed without any wiggle, but it's still fits. That's the one. I forgot to ream that one right there. Yeah, definitely need to be wary of doing that. It needs to go exactly straight in. It's not preferable to be doing this now. Okay, the hole is clean. It should be. Feed it through. I gotta push and twist because I'm actually threading the screw into the plastic right now. Perfect. So screwed it in so it hit the wall. That's not going anywhere, and the joint feels, it's just completely rigid, but you can still get the movement out of it like that when you need to. That's what we wanted. Okay, so I paused it to spare you some tedious parts that doesn't benefit you to watch at all, but I plugged in the extension cable that came with the end stop into it and routed it through the little hoop, and then I routed it back here through a little pinch spot. Let me get there so you can see it. Between the two motors, there's a part in the frame where there's a slot. I just jam it right through to restrain it to get it into this box and stay out of the way of the lid that's going to come down. I've also plugged in the motor wire from here and did the same thing. I just routed it through the little slot. Now this part is more important here. This wire comes to you like this. It's a regular servo extension wire with a female end, and there's a male end in here. And then I break it out to 3 individual female to female jumper wires. I plug them together with a little double-sided male head, and I tape the whole thing together to keep it that way. So now what this allows us to do is to go straight from the servo to these wires, so I can put them where they need to go on the PCB. It's three different pins that are not all next to each other, so that's why this is necessary. Now what I've done is I wrote down red, gray, white to remind myself of these 3 wire colors, what they're going to on this servo, so I'll remember. Let's see. So let's just, it doesn't matter what I pick as long as I'm consistent later. So I'm just going to pick the brown. So this is brown, red, and orange. I'm just going to plug it in like that. And I'll say brown, servo, brown, red, and orange. And I'm going to, that's what I'm going to stick with. And in the middle there, I've got a white, red, black wire in the middle. But I need to put the wire harness on to protect it while it's in motion. So I'll just take this off. It's easier to put it on from this side, so you're not fighting against wires splaying out. Just kind of shimmy it on. Let's go back to my instructions. Right, so servo brown to white wire here. Let's plug it in. And this will be our service connection. If that servo ever breaks down for any reason and you need to replace it, then you'll just have to pull this connection right here and you won't have to open up the control panel. So just shove it in. I'll bring some of this slack back. Took a little too much. And then I'm going to route it through the pinch points. I'll move it here so you can see it. Pinch points there, and I don't need this much slack up there, but I might need it on the other end, so I'm going to feed it through like that. But actually, I don't want to pull it tight because I don't want to be pulling on the motor. I want it to have just as much room as it needs to move and no more. And now with my carriage pushed all the way over here, I'll move it through this piece I've attached. This piece is asymmetrical, so I took the larger opening and put it onto the rod and zip tied it. And now I'm going to take it like that. And now what its purpose is to constrain the motion of the wire harness to prevent it from sitting in the pinch zone whenever the machine homes. Like that. Now it's fully constrained. And this will live right there. I'm going to take, let's see, I'll take this remaining bit here and I'll put another zip tie right here. Just like that, and clip it. And it's going to sit on the far side of this little wire clip there to prevent me from pulling it back through on accident. So now it's fully constrained, it stays where I want it and stays out of where I don't want it. And I'm also going to route it through that little pinch point in there. Now I'm going to start plugging things into my Arduino. I don't know if I mentioned it earlier in the video because I've been doing the small clips on this over a few days, but this comes to you fully assembled. Our motor drivers have to have their potentiometers set. We do that for you because it involves plugging in the motors and the power supply at the same time and then adjusting it with a voltmeter and what it does is it ensures it's setting the current that this is going to use to drive the servo, the stepper motors, and we want to get as much out of them as we can without burning something up. So I do it and then I mark them so you don't have to worry about it. I've also got on here a pin-out diagram that just shows you what all the labeled silkscreen pin connections on this are supposed to go to. I labeled even the unconnected ones too, just so you have it for reference. And I'm going to start connecting things. I've got somewhere here I got this. It was the last part in my soft parts bag. It's a buzzer. It's got two wires coming out of the bottom. The longer wire is the positive one, and you can even see it on the top of here. It says there's a little plus, and I'm just going to plug it into the red jumper wire. And I'm gonna, let's see. Oh yeah, I did do that to reduce the slack. I tied it into a little knot on itself just so there's not so much slack flopping around inside the box. And now I'm going to take that and connect it to D12 is the buzzer positive and ground is the buzzer negative. So there's D12. Now on the PCB, these silk screens here are only the pin that's nearest to them. And these pins on the far side are all grounds, which is really convenient for what I'm about to do. I'll just plug this red one into D12, and then the gray, which is what my colors happen to be. Yours will be different. I'll plug that into the ground. So now that's ready to go. Excuse me. I'm going to plug in my servo. So you want your, let's see, servo yellow wire is your signal, is going to go to Z negative and Z positive. So actually, internally to this PCB, that Z negative and Z positive, that's actually the same pin. Same thing for the X and the Y. So the yellow wire on the servo, blue, red, and orange. I have a different, that's the signal wire. We pause it and figure out the color code. Okay, so I just paused it and looked it up for that servo because servos have two different color codes on this wire here. This one is brown, red, orange, and brown is ground, red is power, orange is the signal. So on this chart here, I want the servo signal wire to go to the Z. So signal is orange, which comes on this end as white. Just go into a Z. Then I want the servo power, which is on this end, it's the gray, to go to a 5 volt. So where's my 5 volts on here? Okay. Right here, these two pins are free and not in use. I'll grab that 5 volts. Let's grab that, peel that wire so I have it. 5 volts. I want to make sure my little jumper wire didn't come unjumped from itself. Oh yeah, it's snuck out of its shell. There, I'm going to make sure it makes a good solid connection. Just like that. And then the red wire goes to ground, and I'll just pick the one right next to the Z for convenience. Servo's connected. Next, I'm going to take the wire, the 3-pin wire that is from the limit switch. We have a red, black, and a green. Where's my limit switch? Limit switch red wire is the normally closed leg. I'm going to put that on Y. That's the red wire. And then the limit switch black center wire is the ground. Now I'm going to put those on the pin that expects it. Where does it go? D10, which is the Y plus and the Y minus. So the red one is going on the Y, the black one is going on the ground, and the green one is floating unconnected in the air because we don't need that. That's the normally closed leg, or the normally open leg. The other one. There we go. It's on there, fully connected. All right, next thing I'm going to do, before I mount this into its case while it's still nice and accessible, is grab the 3D printed Arduino Nano cover. It's a hook and rotate. So it hooks over the end, and you rotate it down, and this thing can bend, and it clips on the underside. And this will protect the Nano from me fooling around in there with my screwdriver, but also, more importantly, it'll give it a place for strain relief. There we go. Oh, it looks like the other parts that are in there don't want that clip to fall down. Let's back it off a little bit. Until there. Until I know that it's clipped. There. So the cover is on. I'll get my USB cable. Ultimately, the reason this is here is because the USB cable into the Nano points that way and the power cable points that way. And I want to cover this whole thing up, so I don't want the make break to be here. So I'll plug in this cable, the tiny one. Oopsie daisy, there's a little bit of 3D printed nonsense in the way. That's not convenient. I'll pull the Nano off the board so I can do this do this right. There, that doesn't belong there. Excellent. I should have done that in the first place. Pull the Nano off and put that on. Plug this in. I will put the Nano back. And then use some zip ties to bring this over the top. Hold it that way so you can yank on the blue cable all you want without ripping it out of the delicate Nano USB mount. Excellent. So now I can drop this in. I will get a couple screws. There's multiple mounting holes in the box that match the Nano. You only need to use 2 of them. You can pick any 2. I'm going to pick 2 that are diagonal from each other. And I'm not going to try to make it so you can see it on camera. You know what I'm doing. I need to be able to see it. Yeah, having this magnet on this tool is really handy for this task especially. Okay, I'm going to take this is the motor cable that's for the long axis. Which jumpers am I going to jump that to? Right, so it's a 4-pin connector, so it could connect on in either orientation. I'm going to connect this one, which is this motor, to the middle stepper driver, which is the y-axis, and I'm going to keep the red wire pointed, let's see, well, the black wire is on the exterior, so the black wire pointing that way, towards the front of the machine. And the consequence of doing this in reverse order would make the motor move in reverse from what you expect it to, and you would notice that during the calibration procedure we're going to do a little later. And if you need to fix it, if you plug it in backwards, let's say this is manufactured a little bit different because it's a different lot or something, and you discover that you need to flip the direction, unplug the power from everything. Take the power out before you pull this wire out. If you disengage this wire while the power is on, it's just intrinsic with this type of driver. You can burn something out. They have too many coils in them, and it can induce a back EMF and just nail it. So this motor, 4-bumper, black wire is on that side of the center driver. It's like that. To be very clear, I know I just said the same thing like 4 times in a row, but better safe than sorry. I'm going to do the same thing with this one and use its little rubber band to hold back some of that stuff. And key it into the rotational axis. That's going to go into your X-axis driver slot. And its black wire is going to be facing that way. The black wires are facing away from each other, which makes it easy to remember. Just like that. Okay, next thing I'm going to do is set this aside for 1 second and get the 3D printed cover that's going to enclose the electronics. Now I've got the vent side facing toward me. I'm going to grab my sticker out of the spare parts bag and put it just like that in this orientation, because this slot is going to go around the T-axis motor, the rotational axis. Boom. And And I'm going to stuff these wires in around the corners, underneath the Nano USB cable is a good spot to restrain some of them. A lot of the extra wire. And then I'll just slap this cover on top. Okay. I just paused it there to stuff those in for a second. I'll give you a little view of what it looks like before I close it up. All the wires that were routed from this moving assembly and the limit switch are routed through that pinch point and down next to that motor. So they're all out of the way. Everything's stuffed under there. It's not going anywhere. And you should, if all goes well, you'll never have to open this lid again. And I'll just say real quick, notice this is where the power is going to come in. So we'll do that next. I'm just going to drop this slot here. It's got 2 locating pins and 4 screws are going to lock it down. I'll add that using this tiny Allen wrench to stuff those wires in that little crevice back there was a useful way to do it. There we go. And I think I've dropped a screw because I've had this project on my table for a few days. So I'm going to grab one out of my spares bag. No problem. And those 4 screws, they create this, they bring together the 2 halves of this enclosure, and that just makes it really rigid. Now it's just this hollow brick. Put this aside. I'm going to open up my cables bag. So this cable is my USB extension cable. That's what I'm going to go onto the end of this blue wire and to go to my computer. This is the power supply. 12 volts, 3 amps. But I wouldn't want to have to plug and unplug this kind of hidden cable jack all the time, so I've included this in the kit. It's a nice little jumper with a switch, and this will live there. So now anytime I want to disconnect the power, I can just flip the switch. And that is almost the entire thing. Flip this around. I actually forgot to finish assembling the carriage here. Flip it around this way. Scooch some of this stuff out of the way. This is going to be my pin holder. I'm going to use a 3mm nut. Let's see. I'm going to grab another one out of my spares. I guess I had used all of them. A 3mm nut, and then I'm going to grab the only long 30mm long 3mm screw. Oh, and 2 nuts. Like that. Two M3 nuts. Feed this. Oh, that's right. That's right. Keep getting ahead of myself. I'm going to take this screw. I'm going to take one of the nuts that I had assembled earlier and screw it on like that. I can put a dab of super glue in there to fuse them permanently, because I never want that to unscrew on me on accident. Excess off. Oopsie daisy. Some of that super glue out of there. I put too much super glue on there. You only hardly need, heck, I probably could have screwed it in and then put a dab of super glue on after the fact. Would have been all that was necessary. Excellent. So now, that's going to be my nice little grabbing point for that part that's going to grip the pen. Now put one nut on the end and push it in. Let's see. Maybe I better start from that side. Push this through. Thread the nut on. That's better. Thread the nut on and then pull it towards you. And then unscrew it. Seat the second nut. And push. And now there's a nut on either side of that. Slowly thread it into both. I'm actually pushing the assembly together while I do this to make sure that it doesn't push something out if the thread doesn't want to thread in. There, now it's in both, so now it's a really durable connection. And I'll just pop it on like that. And you can use these two little nuts to hold it. Now, if you're only going to draw with your pens, then you're done with that. You can use this tool to tighten it as well. But if you want to use your engraver, you'll just take those two nuts off and put this piece on instead. So I'll actually assemble this right now. I've got this piece. The engraver is really simple. These two clips, it's just built specifically for the Dremel stylo. It's just a really lightweight and still very durable tool. Get all of those in my engraver parts bag. So I have this brick. Peel it, and I have some nice acrylic plexiglass, so to keep junk from flying up at me. And I'm going to fit it into place. And this has a nice rough cut edge, so I'll just use that as the top. And then I'm going to super glue it. And while I'm doing that, I'm also going to super glue. There we go. There's 6 magnets in here. I'm going to super glue them into these 3 holes and these 3 holes so that they attract each other. So that'll be what holds the shield in place. And the super glue will also fuse this acrylic to that piece. So I'm going to do that off camera real quick. Okay, I've got those glued in so they'll mate with each other. The glue is dry enough. Just a word of warning is beware smearing glue on this, because even if you wipe it clean afterwards, it'll dry and leave a residue there and make it. And it's really not functionally important, but it just doesn't look as good as it could if you do that. So I've got my Dremel stylo here. Pretty cool tool. You press this button and turn this piece here. I like to grab pliers to loosen it, and that's how you insert the bit. And there's power and then speeds 1 through 5. When I'm engraving, I use it at the lowest setting, but that's just going from memory, and you can still experiment. Actually, I think I turned it up a little bit to give it a little bit of oomph. Regardless, I put that in here. It only fits in one way. It's like form fit with that little groove like that, facing up. And these 2 pieces are both different and both asymmetric. So he fits like this, the lower one. Get these little screws. And just shove it in as tight as it'll go. We don't want the motor going anywhere. The way to get good engravings is to have everything be as rigid as possible. So this piece has an arrow on it. Arrow points up, just like that, because it's almost imperceptibly conical not completely cylindrical in there to contour to the tool. Just like that. Excellent. Now, there's different hole patterns here. This is if you're going to be doing a different diameter of cup. You're going to want to be able to move it up and down more than the range of lift that you're normally able to. So you'll set it at that height, and you're good to go. Set this aside for now and finish up here. I left this piece sitting out. I didn't stick on the little sticky. This is one of the sticky tacks we used here. I got it from the spares bag. I'm going to put it on the end just because that's nice too whenever you're pushing on the bottom of a cup to just, like, you know, give you some conformance there to make sure everything stays happy, and it won't get in your way if you're doing that. Anyway, insert the part, and I did not use my spare bits. I did not use this yet, so the heatsink goes on the motor that is more stressed, which is the rotational one, because it has a large normal load on it while it operates. So just peel this off and stick it on in whatever orientation you want. Push on real good, and that is how you build the CylinDraw. I think in the next video we'll go to the calibration steps. I'll plug this into my computer and run you through what's involved. There's a step-by-step procedure for testing this out safely and making adjustments if necessary before you can start making some drawings. And save this cup because it's going to be the first test piece. So that's all for this video. Thanks for watching.